Thank you everybody for joining. This was what I would call a precursor to, in case some of you are going or not going. As you know, Camet has been working on predictive AI, specifically in manufacturing and supply chain. So today we thought it'd be great to have our advisors, Ron and Bryan, really walk us through what's happening in this vertical and all the great use cases that they have seen, what's working, what's not working. So just some house rules. Feel free to add questions during as they showcase and they talk to the slides in the chat box. And at the end of the session, at around 40 minutes after our talk, we will open it up for everybody to ask directly questions to Ron and Bryan. If everything is okay, I would like to hand it over to Ron and Bryan to present and introduce themselves.
Sure, I'll start. I'm Ron Kyslinger. I'm going to date myself a little bit here, but I've been working with AI since the early 90s. I was at Ford Romeo engine plant and developed the world's first cold test for engines, and it created a bunch of waveforms, a bunch of analytic data, and anytime there was a warranty event, obviously we were trying to go back and filter through it, try to figure out what was going on. So I created a large AI data lake and searchability and so forth back then. I've been doing AI projects past 30 plus years across various different verticals, starting in automotive, but then I went on to integration of equipment for automotive, and then finally into warehousing e-commerce. I was a global officer at Walmart. I was an executive director of worldwide operations, engineering, and design for Amazon. So I worked on next generation solutions for them, forward leaning and thinking AI applications. And then I partnered up with Bryan. We created a couple different companies, one of which is Nexus, which is what we're doing a lot of our AI work from. And with that, I will allow Bryan to introduce himself.
Yeah, Bryan Banish. My background is technology manufacturing systems and automated systems, particularly in semiconductor manufacturing, so large scale product development, multi-year endeavors to create highly automated, highly precise systems, including then, after about 15 years of that, starting a company called Boston Semi Equipment to do that. And in the past 10, 12 years, really been consulting into the automated equipment space in manufacturing, both high tech and in other industrial spaces. And Ron and I have really been able to apply AI, particularly with the agentic AI that's really come to life in the past couple of years, to really solve some interesting problems that, you know, we've kind of hit our head against a brick wall for years and years, and now the technology and the computing power is such that we can really attack these problems. Ron, maybe you want to just take us through a grounding of the kind of AI landscape right now.
Yeah, so let's talk a little bit just very quickly where it came from. So as I mentioned, I've been working with it since the 1990s. I mentioned cold test. Unfortunately, you know, somebody would come back to me then and say, hey, we had a warranty event. I could go back and look and say, okay, I could see that it was still in spec, but it was at the high end of the Six Sigma range. I want to look at other vehicles that were in the same range, maybe had the same waveform, same pattern, went through the same machining processes, things like that. The problem was that the compute power just wasn't there, right? So it would take me 3 days to compute something you could do in milliseconds now. The amount of data that I could retain several weeks worth of data, maybe even up to a month. Now you can do several lifetimes of data and reference that, right? So the power of AI has really come to life as the computing power and the storage capabilities have grown. Now, a lot of people get a little bit confused on generative AI and agentic AI. So a lot of people use generative AI. You can think of a lot of different things that are out there that you can ask questions to, and it will generate a solution or come back with several suggestions for you. And there's many different companies, very large names working in that realm. However, when you look at the application of those in the day-to-day industrial environments, so you're actually putting them into business and trying to drive those changes to the bottom line P&L, there's been very little success in driving things all the way to the bottom line. So it may help you fill out an email. It may help you rewrite something that you were planning to write, or help you generate a PowerPoint presentation. However, the question then is, what business result does that drive forward and actually accelerate? And so there was a study out there that was done by MIT, and they determined that 95% of the AI activity, that is out there has been stumbling and failing to return real P&L bottom line results. And it's because a lot of people are on this left-hand side of the page. They're working with the large language models and discrete tools for some discrete problems, like maybe filling out a form for receiving or something like that. However, what does the person do if that receiving clerk can get their job done in half the time, right? Have we done anything to change what that means to the bottom line? Have we provided them additional skill sets or other things to do with that newly found time? Or are they just taking longer breaks and going out for more cigarette breaks or whatever? So, and then there's, the pilots, co-pilots, and chatbots. While all of these are very powerful and we use them as well, the real power gets when you get on the right-hand side of the page and we start talking about agentic AI. Now, agentic AI, some people get a little bit confused, but basically it is exactly what it sounds like. It's a bunch of little agents that are capable of doing very discrete things, like filling out a form, right? That could be one of them. But it's actually tackling problems that are more complex typically, right? Solving problems that normally it takes a human in the loop or human intelligence embedded into that agent in order to drive a real world problem. So we work on, in the industrial world, which has been, a lot of bespoke solutions, a lot of things that we come in and talk to our customers about. They're often telling us that it's a snowflake. It's something that takes 40 years for somebody to learn how to do. There's subject matter expertise in it. And it's embedding that subject matter expertise, asking the right questions, learning what that SME actually is doing to solve the problem. Because whether they know it or not, whether it's written down anywhere or it's just in their brain, there are certain rules that they follow. There are certain algorithms which they use, which they might even realize they're using. And we can embed those in these agents to solve the problems for them. Very complex problems, things that used to take them 6 to 8 weeks for a human to dig through, parse all the information out, and then come back to a most optimum solution can now be done before that engineer even opens the email. They now are in a role where they can verify and validate some of those things that are happening. So now those things can lead to bigger returns. So think about it. If your competitors are taking 6 to 8 weeks to have their experts dig through the same way you were manually, how much more powerful is it if you can pick up the phone 30 minutes after receiving that RFP and be talking to your customer about, hey, I see something that's out of spec here. Did you really mean that, or were you fat fingered, right? If you really mean that, then we have to talk about what that means for this, because it's going to change the solution set, right? But you're already working on a solution before other people have even figured out what the problem is. Those types of things can really drive productivity and driving bottom line results, because now I can quote faster. I can return solutions faster. I can start validating that, yes, I have found the optimal solution and I have data to back that it is the optimal solution. We don't get into situations where one business unit's questioning another business unit or one person's questioning another person. There's data driving these things, and people now can rely on the data to understand that it's getting us to a result. And so those 5% MIT found are very successful, right? Driving P&L impact. But it's a completely different way of thinking about applying solutions, whether it's generative or agentic.
Ron, I think one thing that we hear in the industry is AI going to take away my job? Am I going to get replaced? And how you can discuss that, because I think that's specifically in manufacturing, we are seeing two folds. One is there's not enough talent to do the job. At the same time, there's this confusion that AI is going to take away the job. Can you elaborate further on that aspect of it?
Yes, actually, we end up going through phases. I'll speak to this a little bit, and then I'll let Bryan add some color to it. But in a lot of our engagements, first of all, it's you can't do it; it's too complex. And then once we start getting into it, the engineers or whoever we're working with starts to realize, holy crap, we can actually do this. It's going to take my job. And we explain to people, we're not trying to take people's jobs. What we're trying to do is take away the arduous work, right? The 6 to 8 weeks of digging through documents, wondering whether you really got the optimal solution, or maybe you missed something. People second guessing you second guessing yourself, maybe making $40 million project that could create, problems and maybe even cost the entire EBITDA for that job, right? The entire margin. And you can sleep better at night knowing that, okay, I'm making better decisions. And it opens up then that person to have more time to actually work on the out of the box type things. Like, can we think about this differently, right? Is there something even more optimal that we could go and try a different solution? We can probe those with agentic AI and actually start presenting them to a human, but the human still is the human in the loop, right? The human still is guiding and directing the end result, right? We do set guide rails, we do ground the AI so it's not going outside of the bounds, it's not trying to solve problems it wasn't designed to solve. However, it does open up different degrees of freedom for an engineer to explore different types of solutions, or a business person to explore different ways of doing business. We often talk digital twin, right? Same type of thing. What can we change? What is that polynomial that we're dealing with, and how many different levers can we change? But what we find, and I'll let Bryan speak, like I said, is that we go from, oh, it's going to take my job, to, wow, this is awesome. Can it do more, right? Can it help me with even more stuff? Because now I've got free time to work on this. I don't want to work on these other things anymore. Let me work on something cool.
So maybe one of the best ways to answer that is to look at a case study. So here is one where I think Ron had mentioned the kind of the RFP aspect. So we see a lot of industrial manufacturers that have, either bespoke or engineered solutions. The process starts with customer launching in, sometimes by data room, sometimes by email. The input's slightly different depending on the company, but fundamentally comes down to thousands of pages of documents that need to be combed through to understand. And really what they're looking to do is kind of extract out of those all the key parameters. So it might be information about the site. It might be information about the associated equipment. It might be information about what to do in emergencies, all different types of documents. And really, those can take upwards of, days, weeks to make sure that you've sorted through and looked for every last remaining key item. But that is a process with agentic AI that can be automated. And almost any manufacturer is really trying to synthesize all of that information down to a couple dozen parameters that drive costs, that drive design, that drive the manufacturing process and the inspection process, right? And Ron had mentioned there's subject matter experts that have 15, 20, 25, 30 years of experience, that they know what to look for and how to approach that. And it's really that process of digesting all that information, sorting it out, getting it into a synthesized view, and then getting back to the client with, did you mean this? We have some missing things, we have some questions, and being able to shorten this loop. With today's computing power, sifting through thousands of pages looking for 20 key specs or 25 key specs, that can be done in 15, 20, 25 minutes of computing time with a handful of key agents sorting all that out. But the real advantage from an expertise point of view is the goal is not to take the applications engineer, in this case, out of the loop here. It's actually to harness their expertise, allow them to do just the key things that only they can do, right? When you have conflicting parameters, when you have, most of the engineers, subject matter experts that we've interviewed have said, yeah, there's a ton of things I could and should be doing to facilitate the business and engaging with the client more, but I spend so much time just sorting through a sea of documentation that by the time we're ready to really engage, we're 3 weeks in, 4 weeks in. But if the first time that they actually open the opportunity and look at the potential job, everything's sorted out and 18 of the 20 key parameters are cleanly figured out, and you can hyperlink back to the documentation, then, and the source material, then you really have, you're putting the subject matter in a role where you're amplifying their time as opposed to eliminating it. And that cycle time, what we've seen is, we can drop 80% or more of the cycle time here. The approach really is kind of three pillars. We talked a little bit about the expert amplification. Again, we're not trying to eliminate people here. We're trying to take that low value work away from them so that they can just, okay, show me the synthesis, show me where the key questions are. Let me start to work from, the hard part. And, when we approach this, we go very clearly after a key bottleneck so that we can find the kind of the P&L impacts. So shorter cycle time means you can quote more, you can get back to the client faster, you can do a design to manufacturing handoff much quicker. And the other key thing that agentic AI really enables is to be very pragmatic about data. It allows agents can be coded with rules. Those rules can be from what the engineer knows, and we're basically digitizing tribal knowledge, such that when that subject matter expert does retire, which is a huge problem in the industrial companies, is the retirement of people who are taking that 20 and 30 years of knowledge with them when they retire. We're digitizing that such that younger engineers can come up the learning curve quicker. Did we answer your question there on?
Yes, Bryan.
On that?
Can you also, as you walk through this use case, I know Ron and you have worked on, industries. You've seen things from packaging issues and how machines were failing. You've seen things in automotive industry where with the quality there were challenges. Can you also bring some of these real live use cases and how that had an impact with ROI?
Sure. So, as I mentioned, I started my career in automotive. I was at OEMs, Honda, Ford, Chrysler. I subsequently worked in the strategy department at Chrysler when it was Daimler Chrysler. And then I ran the strategy department to put together the deal to go with Fiat. So I immediately went to work for Fiat, and I was on the machine tool side now, designing the solutions, installing them, and supporting them. So I've been on the OEM side as well as the supplier side. So many different examples, but to give you one that really impacts both sides, think of robotic solutions, right? So think of a body shop. There's literally hundreds of robots that are welding a body together, brazing, sealing, other things going on. If someone were to come in there and make an adjustment, it could be a small adjustment, could have been made over the weekend. It could impact the throughput of the building. And it was very hard for a human to figure out what was causing the problem. So in that application, we had agents that were trained to actually monitor and track each robot. So what it was doing and the X, Y, and Z motions of everything that it did. And it was monitoring for any changes in those. So if I, stopped production on a Friday evening and I was running at a certain cycle time, and then all of a sudden I start up Monday morning and all of a sudden I'm at 0.3 of a second slower in a operation, I could very quickly dissect that with an agent, and it could kick that out and notify me saying, oh, by the way, this Z-axis motion, it was changed by a human, and it's now 0.3 of a second slower. And while that doesn't seem like much, it's now going to create a bottleneck throughout the day, and you're going to lose X number of widgets of production by the end of the day if you let it continue to run that way. Now, that's very different than monitoring a piece of equipment, same exact piece of equipment, and monitoring it for a potential failure. So the failure mode for it may be that it starts to slow down in the Z-axis. So I see a 1 millisecond delay, then all of a sudden a 2 millisecond delay. And it's even not to the point that it's affecting my throughput yet, but it can actually flag that if you allow this degradation to continue, it's going to impact your productivity in the matter of 3 more shifts. And oh, by the way, if you let it keep running this way, it's going to fail with hard downtime in 5 days. Right? So now you can get your predictive maintenance and be ahead of the downtime events that occur. So you start thinking about the power of those things happening at even a granular level on an individual robot. But trying to monitor all of those robots as a human, and trust me, I know, when I was a young engineer, I was a resident engineer, my plant manager would say, hey, why is this, zone C running 0.3 of a second slower than zone D? Don't know, right? I can go out and find out, but normally it wasn't noticed until we're already losing productivity. That's why we noticed it. It was bottlenecking, and engines are stacking up, or transmissions are stacking up, or we're not getting vehicles out the door. In this case, these agents can be working ahead of time and flagging those things to humans and allowing you even proactively to react. And imagine these things could be very sophisticated. It could be this robot only works on your high-end vehicles. And oh, by the way, you're not running a whole lot of them in the next 3 days, right? I can look out in the future and say, okay, now instead of it failing in 3 shifts, it's actually going to fail in a week and a half because that's your productivity pattern. So you can actually have more time to go after this robot because it doesn't do that motion except on this high-end vehicle, right? So it can get very complex, if you will, for a human to be trying to monitor, should I get out there? Should I change this tool? Should I not change this tool? It's also used in various, and you can think about this, maintenance applications. So where I've applied it in the past is I could have a hard downtime for something. Something broke, a belt on a lift broke. and I've got a human over there working on it, and I know it's going to take them 4 hours to do this repair. But while they're working on it, I have a conveyor problem that happens behind them. Should they leave what they're working on and work on the conveyor problem? Well, normally their supervisor's yelling at them to do one or the other, and they're getting bounced around, and that 4-hour repair turns into a all-day repair, didn't get finished by the end of the day. Somebody's asking why, that should have been done in 4 hours, but they're chasing all these other things. Well, now if you can actually have data on which is impacting your productivity more, right? Maybe that conveyor, okay, it's just a spindle on the conveyor that's broken, right? And yes, things are still moving along. I'm not losing any downtime. I'm not losing any packages because of it. So let it continue to run that way while I continue on this lift, because the lift is more important. I can work on that secondary, right? So being able to put those into the proper stack to focus people's efforts. Again, not trying to replace people, trying to make them more effective, right? A little less chaos.
This is awesome, Ron. So one of the biggest challenges that I've heard is this, there's a lot of buzz. However, there's a slowness in adopting also AI, a lot more window shopping probably. But I think in your world, you've also seen that typically adoption of the initial phases of AI have failed. Can you discuss a little bit more about why that happens, where the gaps are? And I have a question here from one of our listeners. He is probably saying, are small companies usually more hesitant to adopt agentic AI? And he thinks that it is always easier for the larger manufacturers to adopt new technology. I know you and I have discussed this, so I will open up all these three questions.
I can probably jump in there on Justin's question. So Justin, thank you for asking the question. We think there's a sweet spot, at least as an outside technology provider to a manufacturing company. Generally, manufacturers have to be at least a couple $100 million in revenue size to be able to really invest in this kind of effort technology. You're not going to find a $10 million manufacturer that do it. So it kind of, I would agree with your concept of smaller. Just basically, what's your definition of the word small and smaller? So we would say a couple $100 million there. When you do get to the multi-billion, $5 billion, $10 billion companies, a couple things are different. First of all, there's a strong desire or it's a feeling that they need to be developing these things in-house. Like, hey, as a manufacturer, we need to master this technology. If we let somebody else solve this problem for us, then we're foregoing our AI strategy. And that's not true, but that is a reluctance that we see. The other thing that happens when you kind of get above the $5 billion mark in size is they're trying to architect for a corporate-wide, scalable, solve all problems for all people solution. Kind of like hey, we need an ERP that fits every group. What we focus on and what we think is critically important is to go in and solve key problems, find the bottlenecks, whether it's upstream in quoting or downstream in supply chain or some kind of quality issue on the manufacturing floor, but make sure that it's also a scalable, extensible solution so it can reach forward in the upstream in the process and then downstream. So you're not doing a point solution that's isolated, but you're solving a particular problem, getting an ROI, going to the next group, extending that platform, and then demonstrating to the group, hey, it's not just for that one factory, it's for this factory also, or for this business unit as well. And our experience has been kind of the 200 million to 5 billion are the folks that are looking for external help, and that they're not trying to boil the ocean with a corporate solution. And there's plenty of Accentures and IBMs and others that will come in and try to do a multi-billion-dollar solution that's going to solve all problems for all groups in the future. But we think this is the right targeted approach in that sweet spot.
So, sorry, not to kind of take spotlight here, but I just want to separate. So from understand the agentic AI Ronald was talking about, was agentic AI more on the paperwork and on the front end of the business? So being able to have the agent.
That's an example.
Okay, but then there's also the agentic AI that's, let's say, taking data from the machine. So I don't know, maybe this data is stored in an SQL database. It's getting pulled from the sensor, SCADA, whatever. And then you're having your agents, go into different machines, kind of take that data, use your algorithm. So is that under the same umbrella, or would those be two kind of different? Or is this all under the agentic AI umbrella? That's what I was looking at.
Yeah, they're all under the agentic AI umbrella. They're all different agents, and agents can be generated to solve any business problem. And when I say any business problem, I've done it to give you some examples. Sales engineers. We've had sales engineers that go out and call on 5 or 6 different customers in a day. And they might be leaving a plant, and they'll say, hey, I'm in a plant and I'm in wherever, right? So somewhere in Ohio, right? And I'm leaving this plant. And I think there's a tool that's a 60 Newton meter tool on this line, and I want a new quote for it. And so we created an agent where they can be asking those types of things in their phone, literally as they're driving to the next location. And it's saying, give me a 60, the 60 Newton meter tool. And it's like, oh, actually it's a 65 Newton meter tool. And it's actually this tool. And then it's like, okay, when I quoted that last time, what did I quote with that? And it'll say, oh, you quoted 2 battery backups in this power supply. Would you like to quote that? Yes. And then would you like me to put that into the CRM or drop it directly into the ERP? He might say, just park it in the CRM, I'll get to it. And it says, oh, would you like to add service? Because last time you added service. Yes, add service, right? So they're doing these things that typically would have piled up on them at the end of the day. They would have forgotten what one of them was because they forgot to write it down, right? Those types of things. But they're able to now do this on the fly, right? We even have created things for bill of process and ERP entries, right? Where you can go through a 2-year massive ERP undertaking, which any of us that have gone through them, they can be quite painful. Or you can choose to use agentic AI to map some of that stuff. Like, I understand that this part number is that part number. So anytime this engineer puts this in, I know it's this in my master ERP, right? So now the person that's over here in purchasing knows that's what I'm asking for. Oh, by the way, we've got 15 different business units, right? And they might not even know that it's the master company that's ordering it. So make sure that they understand it's the master company so that we're getting our economies of scale on that purchase, right? So there's a bunch of different things that can happen. Go ahead, Brian.
Yeah, Justin, you had asked about it in the context also of what's going on in the equipment, because this is where it becomes critically important, right? As I said, we have to go solve very particular, very specific problems. But once you've solved them, clients don't want point solutions. They want things that then go out across multiple platforms, right? And so if your focus in, let's say, I'm the OEM and I want to have a AI tool that does predictive maintenance on my piece of equipment, that's interesting. But if one line, the equipment on one line does it differently than another one, and there's no commonality across that, that becomes a particular problem. Like, how nobody wants the visualization software only for one piece of equipment, right? What they want is a way to reach across all of the equipment. And if it's working with the OEM specifically to figure out the rules and the failure modes and the failure signatures, to then do the predictive maintenance or any other key predictive problem, they're going to want that same approach applied to the equipment on the next line or the equipment later on down the line. This is why a company like Comet is so powerful in this space, because most OEMs feel the need to solve that problem themselves. Now, they may be good at it, they may not be good at solving it from an AI perspective, but clients don't want point solutions. They want factory level solutions, right? That will cut across multiple pieces of equipment. And that's why the Comet approach is so powerful, and it's enabled by agentic technology. Does that answer your question, Justin?
And I can build on that just a little bit to further answer the question that you asked about the size of company, right? So Bryan is absolutely spot on these larger companies want to own the AI solution. But what they fail to understand is owning the platform, if you will, the enterprise solution is very different than owning every single agent that's been developed, right? So you can allow someone to come on to your premise and solve problems on individual pieces of equipment like Bryan was talking about, or in manufacturing processes in a certain business unit, and create an agent that will do that very reliably over time and embed that agent in your overall solution, right? So it doesn't have to be an all or nothing approach. Too many times they get stuck in an analysis paralysis because the CEO wants to make the perfect decision, right? They're thinking about their job on the line if it doesn't go well, right? These are big investments when you start talking about enterprise across everything. But then a lot of people say, well, show me, I want to see it work. Well, then you're starting small, right? So it's like, okay, so that's why I gave you some of these examples where, yeah, I could have one sales engineer and one business unit that's using this tool and showing that, yeah, he's recording all this stuff. It's dropping it right into the ERP. It's going faster. Created a sandbox to allow customers to come in and develop their own stuff, and it goes directly to the ERP. Now I don't even need a design engineer in the loop, right? On standard products. There's many things like that I can be doing that the CIO wouldn't be the person that has the expertise to solve those problems. That's why you bring in a Comet, you bring in some other companies that are capable of solving those problems using those agents as part of the overall solution. However, it's sometimes very hard to get the IT folks to understand that they can divide and conquer. They can bifurcate a solution, but still own the overall overarching AI platform.
This was great, Ron. I think you answered a lot of the following questions I had, but I still want to come to two big things. One is, why do adoption of AI fail? And you did cover something about the data piece of it, and what does a deployment look like after 24 months? How should we measure success? I think these are very important differentiation that our customers should know about.
Bryan, do you want to take that and I'll add color?
Yeah, I'll just jump into the first one. What really causes the AI to fail? So why adoption initiatives kind of typically fail, right? We see three kind of traps that many people fall into, and it's kind of almost a progression, right? The first is kind of the data fallacy, where AI requires clean data, clean structured data. We're going to take 12 to 8 months to pull this together. Then there's the process alignments problems. Okay, we've got to go figure out all the best practices, put our workflows in place, and standardize that across all the different groups. And then, we've got to we can't start until we get the ERPs aligned, the MESs on the latest rev, and, their CRM systems are fully enabled across all the different sales teams, right? Each one of these are ongoing issues and ongoing problems that don't actually ever finish. And just because companies are changing, they're folding in, doing acquisitions, releasing new product lines, things like that. And so what we see is there's a fairly decent upfront budget that has kind of a Gen AI heavy co-pilot approach. while some team is off doing the data preparation, and the timeline starts to slip. And then it leads to kind of chatbot answers and FAQ, but by and large, a limited deployment, particularly around anything that has P&L impact. And then before you know it, the $500,000 to $2 million budget's been used up. You can't describe your ROI to the CFO, and it really just starts to slow down. So that's kind of the typical approach that we see. And, Ron, maybe you want to take the second question of, where does it end up when it's kind of a platform level? What does it look like?
Sure.
A couple of years out.
Yeah. So if it's done right, as Bryan was pointing out earlier, right, we can start in a business unit. We can solve a problem. We'll solve that business challenge. We start creating a vision for where this is going to head. Right. We start building out a strategy on what's the roadmap to implement AI across different business units, across different processes. What are the bottlenecks that we're going to encounter? And we obviously want to know those bottlenecks quite well, because it's the breaking of the bottlenecks that shows bottom line P&L results that people get excited about. So they want to continue to apply it elsewhere. Right. So typically, you can see the business challenges listed on here. A lot of times people have unclear product visions, where they're going to go. They don't understand their competitive market sometimes. They lack predictive analytics or root cause intelligence. So you get into some of the operational things that I was talking about before. They can have operational blind spots, but as I was talking about earlier, you could have just a maintenance person getting pulled in 3 different ways, right? And they're not being effective in the way they're utilizing the manpower. The solution sets then that we start working on is we have to understand the customer and the product fit strategy. So what I'm talking about there is we analyze what the business needs. So unlike these, 5 billion and up companies, like Bryan mentioned, you can get these large companies that come in and try to sell you these enterprise massive solutions, some giant SAP or something else like that. They're, first of all, very costly, but 2, you have to adapt your business to them. That's the reason why a lot of these things fail, right? Somebody that's a business expert, subject matter expert, that's been doing their business a certain way for, say, 35 years, is not apt to just turn around overnight and start changing the way they do their work. And often it becomes more arduous for them, because they now have to manipulate the data to put it in the way that the actual overarching solution that's being thrust on them needs it, as opposed to having an agent take it from what they currently have, pulling it from a file, pulling it from a spreadsheet, pulling it right off their laptop if we need to, all the way up to the point that we get it into a database and create the solutions for them. And it's almost seamless to them, right? They shouldn't feel like they're having to arm wrestle the way they do business. Right. We do, the category and competitor mapping. A lot of times people don't understand who their competitors and who they're actually competing against, and why accelerating certain parts of their business is a competitive advantage. The feature and competitor analysis, resource and implementation plan. So working through what resources do we actually need from that company. Sometimes people think, okay, if you do AI and we outsource it to you, does that mean we're reliant on you forever? And the answer is, well, no. We can easily train your internal people to take it over. So talking about a blueprint for a successful transition plan, right? When do they take it over? What parts of it do they take over? And then actually, defining the value delivered up front, so that people understand when you've met the goal. Because what we see on a lot of these are scope creep, to the point where It's like, okay, this is really cool. What if I can do this? Well, what if I do that? Can I put my name at the top of the document? Can I do this? It's like, well, yeah, we can do all of that. But what benefit does that have to the bottom line P&L of the organization? So let's talk about hitting those goals and metrics first, and then we can put all the niceties in it along the way. Some of them are pretty expensive. You can do them, niceties to have. Other ones, it's like, okay, do we really want to divert ideas and everything else on solving the 2% problem when the 98% problem hasn't been solved yet, right? So keeping people focused is another one. But by the end of the 24 months, you can now have an orchestration of a bunch of agents. So individual agents solving different problems in the business. Here's a view of one of those for manufacturing. So as I mentioned before, it's about getting data into the data lake. We have a rules engine. We have, data analytics and sync that happens, and data integration. So all that's happening at this orchestration service, if you will. But it's now done in apps so that people can have a training app or a safety app or a quality app. So it's doing the different things that they need it to do, and giving them a roadmap in which ones need to be solved first, rather than trying to boil the ocean, as Bryan pointed out. And underlying all of this, you can see, the IoT data services and device services and so forth. And we can be pulling stuff from PLCs. We can be pulling them directly from sensors. A lot of times we'll come in and we have machines that we've encountered that are dumb machines. And when I say dumb machines, they don't even really have a PLC. They have a little safety card in them, and it just knows that there's a person on a mat or they hit an e-stop. That's about it. And then they want to say, can you make this thing smart? And it's like, well, sure. There's a lot of things that we can do in order to implement it or integrate it with sensors and so forth, so that now it can talk to the things around it, right? It can communicate.
This is awesome. Ron, I know we have, I would like one last review of the architecture paradigm comparison, but before that, and before we open it up to the audience for asking you a question, I know we have some customers who are from the supply chain industry, and you've done a lot of work at Amazon, Walmart. Can you give some use cases, one or two, with equipment issues and machine failures that you have seen and worked on?
Sure. There are some easier ones. There are some very complex ones, meaning that some of the easier ones, I joke about it, but in receiving of some of these large companies, Amazon, Walmart, and others, there are not standards like there are in automotive. So back in the 80s in automotive, there was a consortium between the big three, GM, Ford, and Chrysler, and they created US Car, and they created these standards of what a VIN number is or what a part number is. And so if you were to give me a VIN number of a car, I could tell you how many doors it has. I can tell you when it was manufactured. I could tell you what line it went down. I could tell you what engine it has in, how it's mounted, right? If it's transverse, how many gears it has, right? All of those, if it's electronic or manual transmission, right? All those different things are built right into the VIN. When you start getting into supply chain, there has not been any consortium like that. So you have companies like Unilever and Kraft and these other companies that are quite large. And if a company, even the size of Walmart, comes out to them and says, hey, I need you to change your barcode, they'll tell you to go pound sand, right? Do you want to sell my stuff or you don't, right? Like, this is the way it's packaged. This is the way you're going to get it, right? So the package number that's on the outside, the barcode, may mean nothing to anyone other than the manufacturer themselves, right? And so, yes, I can weigh a product that's coming in. I can even laser measure it. I can say, okay, it's a 12 by 12 by 12 box. It weighs 10 pounds. I think it's the hand soap. I kind of recognize a Procter & Gamble symbol on it. I think that's what it is. But then I cross-reference the manifest on the truck, and there's 7 different hand soaps. There's a lavender, there's a lime, there's a Pava Free. There's like, okay, now which one is it? So I joke and I say it's like Christmas in receiving, right? Because I don't know what's going to be in the box until I open it. But now using some AI, using some knowledge base, right, on how often I'm receiving this, how much I have in stock, how the vehicle was loaded. There's other things that can also go into solving that problem, right? Embedding that information so that now it's in my ERP, right? So if it's not in my ERP, it's not in my WMS, when I go to fulfill the product, right, I can't robotically fulfill it yet. So let's think of I'll give you an example. I have teddy bears, right? I could have 12 of them come in a pristine box, and it's got a picture of the teddy bear on the top and the color of it. I can train that to be knowing that that's that teddy bear, and I know I'm going to pick it. I'm going to place it on the conveyor. I know where it was stored away, no problem. I'm going to pick that box with a robotic arm. It's got a giant pneumatic suction cup on the end. I pick it up, no problem, automated all day long. But totally unbeknownst to me, right, a few weeks later, a supplier decides to change that teddy bear from being in individual boxes, like when I tore the big box open, each one had an individual box in there with the color of the teddy bear and the marking, to now they're in cellophane baggies. Now the glare on the light is so bad, I can't even tell it's a teddy bear, let alone what color it is, right? And my picking mechanism goes from a giant suction cup to needing little suction cups pulling in separate directions on the bag to pull it out, right? And then next thing, totally unbeknownst to me, it comes in as a mechanical pick. So now I open the box and it's just a bunch of teddy bears in there, just like they'd be sitting on a child's bed, right? I can't pick that up with an pneumatic pick, right? It's going to be a mechanical gripper, right? So some of those things, while they're not communicated well coming into my facility, I can track them through the agentic AI, knowing what attributes they have and so forth, and now feed them in the process to the right pieces of equipment to solve the job effectively. So in other words, I know that when I put the teddy bear away, I know where I put it in my WMS. So it says, hey, I'm picking this teddy bear on level 3, zone 2, section G3 of my pick module, and it's a manual pick module, but I know that that teddy bear is pink with yellow polka dots. Well, who would have thought? Right? If I just throw that at a robot, the robot's chances of picking that correctly on the first time, right? Not knowing whether it's in a box, a baggie, or mechanical, or not knowing what color it is, the chances of it picking are really, really low. But now if I purposely say, okay, I know it's a mechanical pick, I know it was one of the last items that was put in the box, right, or in my tote, and when it comes over to the robots that are consolidating and packing a box, I'm telling it it's pink with yellow polka dots. It's a mechanical pick. I'm going to send it to the robot with the mechanical gripper so that it has the best chance of picking it. I might even have multiple pieces of equipment, and one piece of equipment is better at color coding and identifying the teddy bear than another. And so I'll send it there. I may have different packaging pieces of equipment. So one piece of packaging equipment's better for the teddy bear than than a glass light bulb or a basketball. So I need to move those things accordingly as well. And so if you have a human trying to make all of these decisions, what I find is a lot of times those things get missed in a WMS, right? All those rules, right? As I mentioned before, you can have a subject matter expert. All these edge cases often get forgotten until they happen. And when they happen, somebody will say, yeah, we didn't program that, but it doesn't happen that often. So yeah, we'll get to it the next release. And 3 years later, it's still not released, right? That's the problem. And so to be able to tune those very complex systems and be able to manage the flow of all of those goods going to where they need to, so that I keep the productivity, the uptime. I put it in the right packaging so that it doesn't arrive damaged to the customer. I'm putting like items in boxes that belong and can play nice together. I'm not putting a bowling ball together with a laptop, right? Those types of things, right? Even people laugh about it, but those types of problems can happen if somebody has manually hard-coded something into the system and then a SKU changes, right? And that's part of the problem. So those systems can get very complex just because as we started the process, you think about all the robots and all the different things that are changing and trying to get a person to pick up on a manual change, like somebody went in there and changed one little motion of one little robot and realizing it's affecting productivity. That's extremely difficult. In warehousing, it's a bunch of those types of things going on, and they've got much less what should I say, much less more rigor around how it was designed because they didn't have a US car setting standards.
This is awesome, Ron. I know we're coming close to the end. I want to keep it open for everybody here to ask questions directly. For everybody over here listening, Camet is, so Ron and Bryan, just in case if I didn't mention, they are our advisors at Camet. So you can see how much of amazing information we get from them and support in really helping our customers with their use cases and their problems. So thank you for joining, and I'm going to open this up. Please feel free to ask questions directly to Bryan and Ron. Anybody going? Eric, Anthony?
Well, we either put them to sleep or we answered all the questions. Maybe a little bit of both.
Go ahead, Eric. I already asked a question.
Oh, I was just going to say I enjoyed it. Unfortunately, I only have 2 minutes to get to my next meeting, so I can't really ask a question in time. So
Okay.
It's okay.
We'll
Feel free to follow up later then if you'd like.
Yeah, we'll get to you, Eric. Thank you for joining, Eric.
Yep.
Ed Shapiro, I know it's been a while. We've connected. If you have any questions, Anthony, Mario, Justin, any other pending questions on your end?
Honestly, I have a million, but I'm obviously going to ask one in respect to everyone's time. Yeah, I guess my background, I've been a sales engineer for the last 5 years. I've started doing some independent consulting with a robotics engineering background. And like I see agentic AI like in manufacturing is the future. Like I don't look anywhere and not see where it can be used. You know what I mean? So I guess when you're talking about these types of models, I heard there's a way, like, is any of it cloud computing or is it all going to be done like on customer site? Because I know data's sensitive, right? A lot of these people, they're worried about AI because when it's getting processed, like where's that data going and stuff like that. So how are you guys doing all this processing? Do they have servers on site? Do you have your own servers?
Yep.
Is it cloud? Is it on site? And there are latency issues with that?
You can do both, obviously. We have customers that want both directions. We prefer to do stuff in the cloud. And the reason we prefer to do stuff in the cloud is because then we, meaning our front end, back end engineers, can actually make changes, update things, provide additional functionality very quickly. We can monitor how things are running on that ourselves. When you put it on an internal server, it slows down your ability to monitor how well the AI is functioning, how quickly it's responding, right? Things like that, especially for things like Copilot, where somebody's interacting with it and saying, give me the 3 VINs that had this issue or created that problem or whatever, and understanding how quickly it's responding to those things. But we can do both. We prefer to have a lake in the cloud, and there really is no latency per se, because the way we set it up is we listen to data, meaning we don't change the original source of data. So if the source of data is a power tool, it's reporting through ProNet or something else, we're just listening to that traffic and pulling off a copy of it into our own database that we can then access very quickly to provide information and notification, right?
We're at time, but I wanted to just interject. And Justin, your implication is that in cloud, there's a security risk, or there's someone's going to learn on our data, that kind of thing. So one of the nice things is most of the cloud providers, whether it's Azure or Google, or they will provide LLM models that are secure, and they're already a cloud provider that says, look, anything that's within this tenant is not going to be used. And so they have security policy. And so if you use LLMs within that that tenant environment, you get all the protection that's already in a company's cloud environment, so that you're not really risking the exposing your data.
And one last parting thing, I try to explain to people, their data, while it's important, is important to them. Meaning, if I gave data from Amazon to Walmart, their processes are so different. And I can tell you that because I worked at both places designing their processes, right? But if I gave them their data, they can't do anything with it, because that data means something completely different running a Kiva system versus running, a Canap or something else, shuttle or whatever, right? So it's really the knowledge, right? It's the information that you generate from the data that's powerful. And so I tell them, protect your information, right? But don't worry about the data so much to the point that you're, we can't let a single piece of data go. Well, it's all encrypted both directions. Even if your competitor saw it, they get a torque off of a power tool. What are they going to do with that, right? It's one piece of 1,500 fasteners, right, on a product that does nothing for them.
Thank you. So I know I kind of dominated the question space, so thank you so much. Do I have permission to reach out to you guys offline if
Sure.
Absolutely. Yeah.
I really appreciate it. I just saw this ad randomly online. I'm so happy I joined. It was super cool.
Connect on LinkedIn or do whatever. It's fine. Yep.
Well, thank you so much for your guys' time.
Sure.
Thanks,
Sure.
everyone.
Thank you, everybody. And we'll reach out to you separately. Thank you. And have a nice day. Bye.